In this video, I will use the technique of integration by substitution to evaluate each of these integrals. So in the first case, I noticed that the cosine function is the cosine of a fourth degree polynomial function. And then I notice a third degree or a cubic function outside. Now, the derivative of a fourth degree polynomial function is precisely a cubic function. So I'm thinking that this is probably ripe for integration by substitution. If I make the substitution that u is equal to x to the 4 plus 2, then du would be equal to 4x cubed dx. Okay, so now I'm going to see how I can make use of this to simplify the integral. So first of all, I don't have a 4 anywhere in here except as an exponent. So what I can do is I can divide both sides by 4 and get a quarter du is equal to x cubed dx. So as that's the case, my integral will now become cosine of u. And then the x cubed dx part is precisely equal to a quarter du, right? So then this would be 1/4. I could put a quarter here and du right here. Simplifying this, I end up with a quarter times the integral of cos u du. Okay? And so that makes it really easy because the antiderivative of cos u is precisely sine u. Okay, but u, as we know, is the fourth degree polynomial function x to the 4 plus 2. So I end up with 1/4 sine x to the 4 plus 2 plus c. Okay, let's take a look at the second example here. In this case, we've got the integral of, it looks really complicated, but I do notice that the radicand here is a quadratic, the derivative of which is a linear function. Okay, so again, I notice that a function and its derivative appear in the same integrand. So I'm thinking maybe integration by substitution will work right here. Okay, so let's let u, I have some space here so I could write it over here. So let's let u equal to 1 minus 4x squared. So then du would be equal to negative 8x. Okay, dx, don't forget the dx. And negative 1/8 du, if I divide both sides by negative 8, would be equal to x dx. Okay, so here's my x dx. So I can replace that part of the integral with negative 1/8 du. So I'll do that right away. So negative 1/8 du. Okay, so that piece is my x dx, so I've covered this and I've covered that. And then I've got 1 minus 4x squared, which is in fact u, in the denominator square rooted. Okay, so cleaning that up, I'll end up with negative 1/8 times the integral of u to the half would be the square root of u. But if that's in the denominator, then I really have u to the negative half du. Okay, so the integral, or sorry, the antiderivative would be negative 1/8 u to the positive half times 2, actually. Right, u to the positive half divided by half, but division by half is the same as multiplication by 2, plus c. And so I end up with, now the negative 1/8 times 2 is really negative 1/4. The u is really, if I back substitute, is really equal to 1 minus 4x squared. But then that's square rooted. Okay, so maybe I'll write it this way here. And then plus c. Okay, and that's how integration by substitution works.